Hello guys, my name is L. Arigaran. I am studying in Tech Tech Dr. Ramananjan Dr. Samundara Engineering College. I am doing my final year project. My teammate name is Sanjay E. Um, my internal guide is Dr. J.P. Veeramalani, Assistant Professor. Co-guide is Dr. S. Gomadi, Assistant Professor. External guide is Mr. Priyanka B. Process Engineering, Vinum Kothari Petrochemical Limited, Manali, Chennai. Our project title is The Study of Protection of Polybutane and Design of Reactor and Vacuum Flash Column. Our objective is to removal of butane compounds from the LPG reactor mixture manufacturing of isobutylene. The design of vacuum flash column was undertaken. Also designing the reactor to improve the quality of polyisobutane. Um, our abstract is the project. Our project is optimized and catamized polymization process involved of polymization of isoline production of polymer called polyisobutane. The undergoes of fuel bed reactor packed with catalyst. The catalyst name aluminum trichloride. It is to improve the product produced as a byproduct which affected purity of polyisobutane, namely butane and unreacted butane, the compound present in a field. The LPG mixture is entered to the reactor, which is removal of top product. Our project aim to the reduction of the unreacted butane compound to increasing the efficiency of the reactor by the theory by fuel bed reactor designed to improve the efficiency of cation polymerization. uh, by there are using the two methods of column parameter, Markup theory method and resistance force equation. The company profile is Kothari Petrochemical Limited. It is a part of the HCL Kothari groups. There is a largest production quality of polybutane in India. The final year 2007 to 2018, the Kothari Petrochemical is a commissioned second plant in Manali. It is a double the production capacity, uh, 2000 22,000 metric ton per annum in order to supply the polybutane of worldwide. IUPAC name is polybutane, another name is polyisobutane and butane in rubber. Yeah, my project name raw material is LPG. It is used to catalyst cracking of the crude oil. The amount of isobutane in field is 25%. Catalyst using in our project aluminum tetrachloride AlCl3 and caustic soda. The reaction involved in reactor is a cationic polymerization. There is a few mechanism: indentation, propagation, chain transfer, and termination. Mm. Your project is a project flow diagram, block flow diagram, feed preparation, reaction section, neutralization section, and fractionator section, and product storage and handling. The feed preparation. The feed preparation is the section involved in removal of impurities in a field LPG stream. The sulfur and caustic gives the feedback to removal of the caustic wash drum and water wash drum is responsible. Reactant sections, the impurities in the feedstock, it is a fuel bed reaction. The catalyst of polymerization is isopolylene is take place in presence of aluminum tetrachloride. Nutrition section is the catalyst and the unreacted butane compound are involved and they are using in washer wash drum and debutanization as well. Saturation column, it is column the lighter and heavy polymer separated atmosphere flash column and vacuum flash column. Work done. We are work done in our project is overall material balance in plant, overall energy balance in plant, design calculation of reactor and design calculation of vacuum flash column. The basis per annum production is 8,760 metric ton per annum. Production of per is 1000 kg per hour. Our material balance of reactor, the right polymer is 11%, the polybutane is Yes, total is 1100 kg per hour. Polybutane plus light polymer is equal to 1000 kg per hour. The isobutylene 25% and polymer is 21%. Um, we are calculating the amount of certain the unreacted isobutane rate is 200 level per 42 kg per hour. Due to heat production, the unreacted isobutane and the steam of evaporation absorbing the heat. The heat of the reaction is 9348275 kg per hour. The flow rate of butane vaporization m is equal to q by lambda. Lambda is vaporization butane. The butane vaporization, the amount is 2212.58 kg per hour. The liquid is 1751.7 kg per hour. We are balancing of the feed composition and product composition. There are the same amount of 5303.76 kg per hour. Our project comes equally balanced 5303.76 our material balance of vacuum flash column. The butane is 10,000 kg per hour. The light polymerization 38 kg per hour. The light polymerization separate the top product. The balance of polybutane is down product. We are calculating polymer and light polymer and product also same. The energy balance of the reactor we are calculating q in q out. There are the constant value. Heat of the polymer station is 93482.675 kg per hour. Energy balance, the enthalpy of the feed and the heat of the reaction plus q enthalpy of the uh, product. There are the same. There are the ends. Q is the negative rate is endotomic. The heat is the m polymerization butane. Q is the m into lambda. The m value is 2403.4 kg per hour. Feed composition and product composition also some. We are calculating the vacuum flash column of energy balance. Energy balance for vacuum flash column. Energy balance is equation q out is equal to 371795 to 8.2 kg per hour. Q is 425612.7 kg per hour. Q in equal to q out plus heat rotation. Q is equal to 5381.5. We are the vaporization of the polymer station 58 point. The latent heat is equal to other. Q is equal to m into lambda. M is equal to 48.93 kg per hour. We can calculating the q amount of mcp is equal to delta t kg per hour. There are the feed composition and product composition also some. Also same we are producing design. We are going to design of the reactor. Isopolymerization is we are taking catalyst for butane and unreacted isobutane of design of reactor. Given data, when the material use carbon steel of the reactor and polymer is 920 kg per meter cube. The polybutane is 1300 kg per meter cube. Joint efficiency is 80%. Corrosion allowance 2 to 4 mm. The pressure of reactor 12 bar. We convert it into kg per meter square is 12236. The design of production is parameter is volume of reactor, length of the reactor, diameter of the reactor, and thickness of reactor, and top sphere of the enclosed can be named as T. T, we have the amount of the volume of the reactor 6286 liter. Length of the reactor is 3.17 meter, and diameter of the reactor is 1.587 meter. Thickness of the reactor we can be used 0.016 mm. The top sphere rate is enclosed T is equal to 0.0125 mm. We can be design of a vacuum flash column. Design of data of the A is a polybutane, B is a light polymer. We can be basis is 1033 kg per hour. Our design of the reactor, we are using the reserve force Echelon and Fink's equation. uh, the summary of we can be flow rate of liquid session and flow rate of vacuum relative volumetric theoretical number of plate used in design is 17 to improve the of efficiency. Area of column 1.53 meter and diameter of column is 1.39 meter, and height of the column is 3.48 meter. The volume of the column is 5280 liter. Is meter cube is 5.328 meter cube. The conclusion is that the white Google demand the polybutene is one of the most important production of the very commercial applications. The project was done by manufacturing butane accounts of production about 817 metric ton of polybutene in our project. Overall polybutene has been studied. The material balance and energy balance of various equipment involved process can be calculated also study. The study their efficiency can be reacted slightly increasing the also production unlimited butane compound can be minimized. The secondary the design of vacuum flash column is incorporated, and design of vacuum flash column is base of ASME code. So American standard mechanical engineering code. So it is a separated polybutane from the impurity and highly efficiency. The safety measure can be studied also. Cost of equipment of the project estimated, and several aspect of safety and environmental concern has be discussed. Reference we are taken, and thank you.